Hi, today I'm going to show you how to complete the square in order to solve a quadratic function. So this is just one method of solving. There are several different ways that you can solve a quadratic. This method in particular works if you cannot factor. So for example, I have this equation here, and if I tried to factor this, you would want to figure out what multiplies to the back number, -2, that adds up to the middle number. Well, there is just no number that multiplies to -2. The only option would be some combination of 1 and 2, and there's no way that that's going to give you a 6. So this quadratic function is not factorable. So we're going to learn how to complete the square. It's kind of a lot of steps, but I'm going to show you a few examples, and then you'll have this video as a reference. So the first thing you want to do when you complete the square is to isolate the letters, the x's. We're going to keep these on one side, and we're going to move this constant over to the other side. So to do that, I'm going to add 2 to cancel those out on the left-hand side. Then I'm left with x squared plus 6x equals 2. The next step is to find the number that's going to make this left side a perfect square trinomial so that we can factor it into something squared. So I like to call this the magic number. In order to do that, you take the b value, divide it by 2, and square it. And that's my magic number. So in this quadratic, the b value is +6. So if I take 6 and divide it by 2, you get 3, and then when you square it, that's equal to 9. So the magic number here is 9. I'm going to add that to both sides of the equation, because what you do to one side, you do to the other. So now when I rewrite this, I have x squared plus 6x plus 9 equals 11. So this step right here, we completed the square so that I can break this left-hand side down into a binomial squared. If I factor this, x squared is x and x. What multiplies to 9, that adds up to 6, is 3 times 3. I can then rewrite that as x plus 3 squared because they're the same thing twice, so I can write that as squared. And then I still have the equals 11 on the other side. From there, now we have something squared by itself. You can square root both sides. When I square with the left, square rooting cancels out the square, and you're just left with x plus 3. And then you see if you can simplify this any. So 11 itself is not a perfect square. It's an irrational number. And I can't simplify that radical at all because there's no perfect square that goes into 11. So I'm going to leave that a square root of 11 or radical 11. But you do need to add a plus or minus sign in front of it. Then we have one more step. X is still not quite by itself, so we're going to move this 3 over by subtracting it from both sides. And then we can write our final answer is going to be -3 plus or minus radical 11. And I can leave it just like that. But just know that that means there's actually 2 answers. It could be -3 plus square root of 11 and -3 minus square root of 11. So if you graph that parabola, it's still going to cross in 2 locations. All right, let's do one more. I'm going to go a little bit quicker this time. So again, if I set this equal to 0 and tried to factor it, it's not going to work. So I'm going to use completing the square. Step 1 is to get the letters on one side and any numbers on the other side. So since I already have the x's over here, I can leave those there, but I do want to move this 4x over. So to do that, we need to subtract 4x from both sides. Those go away, and I'm left with x squared minus 12x, and we have -24 on the other side. Now we're going to find what I call the magic number and add it to both sides to complete the square. So again, my magic number is the b value divided by 2 and square it. So my b value here is the number in front of the x. It's the -12. So -12 divided by 2 is -6. And then when you square it, you get +36. So my magic number here is 36. I'm going to add that to both sides. So So now on the left, I have x squared minus 12x plus 36 equals 12. And the whole reason I'm doing this is because now this would factor into the same thing twice. So I'm going to skip that middle step and just write it as something squared. When you think about what multiplies to 36, that adds up to negative 12, that's the same number. It's negative 6 and negative 6. So if I shorten that, it just becomes x minus 6 squared. Now a shortcut is, no matter what's here, this is always half. It's always half the b value. So negative 12 cut in half is negative 6 equals 12. Now I have the squared just by itself, so we're going to square root both sides. On the left, the square root cancels out the squares, so you're left with x minus 6. And now I'm going to see if this can simplify it all. So 12 itself is not a perfect square. If I do the square root of 12, it's going to be a decimal, but there is a perfect square number that goes into 12. So I'm kind of going to sidebar over here. 12 can be rewritten as 4 times 3. The square root of 4 times the square root of 3. Well, the square root of 4 is 2, and the square root of 3 can't be simplified anymore. And then since we're solving a quadratic, you have to remember to put the plus or minus in front of it. So that's what I'm going to write here, plus or minus 2 radical 3. And then the final step is to get x by itself by moving the 6 over. So we're going to add 6 to both sides and write my answer as 6 plus or minus 2 radical 3. There you go. Hopefully you enjoyed this video, and you can rewatch it if you need to go back through the steps, and hopefully that helped.